Show a language model a picture of a dog on a skateboard. Ask it what is happening. In 2015, that question was a research paper. In 2021, CLAP made it a benchmark. In 2023, GPT-4V made it a chat feature. 8 years, from novelty to product. The whole story of multimodal NLP compressed into one arc, and it changes what the word language model even means. Welcome back to Lecture 10. Today, what happens when text stops being enough? When the model has to look at pictures too. We'll cover image captioning, visual question answering, clip, and multimodal LLMs, like GPT-4V, and you'll see why grounding language in vision was one of the biggest quiet shifts in the field. Phone-covered dialogue systems. 60 years of chat interfaces. All text, all symbols. But every language you have ever spoken lives in a body that also sees things. If a friend says, "Look at that," the word "that" points at something in the world. Text-only models cannot do that. They only know the shape of words next to other words. Today's puzzle. If a language model can learn from words alone, why should we bother giving it pictures at all? Answer: because grounding matters. Because half the words in the language are about things that exist in the visual world. And because when you tie words to pixels, you get a model that generalizes in ways the pure text version cannot. Today's 3 beats. First, image captioning and visual question answering. VQA in 2015. The first serious benchmarks that asked models to describe and reason about pictures. Second, clip. Radford 2021 at OpenAI. Contrastive pretraining on 400 million image-text pairs. The paper that reshaped vision. Third, multimodal LLMs. GPT-4V, Gemini, Claude 3. What it means for a chat model to actually see, and what still does not work. Beat 1. Image captioning came first. Around 2015, Vinyals and co-authors at Google shipped a paper called Show and Tell. Take a convolutional network that reads a picture, take an RNN that generates text, stitch them together, feed the image features into the RNN as the initial state, train on a huge set of captioned photos. Out the other end, a model that can look at a picture and produce a sentence about it. Same year, VQA, visual question answering. Antol and co-authors, ICCV 2015. Instead of asking the model to caption a picture, they asked questions about the picture. How many people are wearing hats? Is the umbrella upside down? What is the person on the left holding? The model had to combine an image encoder with a text encoder to answer. It sounds simple. It was extraordinarily hard. Because getting the answer right requires actual visual reasoning, not just object recognition. For the next 6 years, both fields, captioning and VQA, advanced steadily but slowly. Every paper was a specialized architecture for a narrow benchmark. Every new dataset got dominated by the model built specifically for it. The whole subfield needed a shakeup. It got one from an unexpected direction, not from a bigger captioner, not from a smarter VQA model, from a contrastive pre-training paper that treated captioning as a side effect. Beat 2. Clip. Alec Radford and co-authors at OpenAI, 2021. The paper title is Learning Transferable Visual Models from Natural Language Supervision. The idea is beautifully simple. Scrape 400 million image-text pairs off the internet. Train 2 encoders in parallel, one for images, one for text. Train them so that the embedding of an image and the embedding of its own caption are pulled close together and everything else pushed apart. Once you have that shared embedding space, you get an unreasonable number of downstream tricks for free. Classify an image without ever training a classifier. Just embed the image. Embed the label text a photo of a cat, a photo of a dog, and pick whichever text embedding is closest. Retrieve images by text query. Retrieve text by image query. Search a photo library with a natural sentence. All of it, zero shot, no task-specific training. Clip kicked off a small revolution. Every text-to-image generator you know, DALL-E2 Stable Diffusion, Midjourney, uses clip or a clip-descended text encoder to steer generation. Every open vocabulary object detector after 2021 uses a clip-shaped embedding as its label space. And it turned out you did not have to design a special architecture for captioning or VQA. Enough of a task lived in the shared embedding that a plain LLM head on top could handle both. Beat 3. Multimodal LLMs, 2023. OpenAI ships GPT-4V, Google ships Gemini, Anthropic ships Claude 3. All three take a chat-tuned LLM and staple an image encoder onto the front. Paste in a screenshot of a receipt, ask how much did I tip. Paste in a photo of a whiteboard, ask summarize what is written. Paste in a broken chart, ask what does this show. The chat interface did not change. What the chat can consume did. Under the hood, most of these systems use some variant of the same recipe. A pre-trained vision encoder, often clip-descended, a projection layer that maps image features into the same space the LLM already speaks. Then, the LLM handles reasoning and language. The vision encoder does the seeing, the LLM does the talking, and the projection layer is the translator between them. But, and this is where you have to stay honest, multimodal LLMs still hallucinate wildly on images. They will confidently describe a person who is not in the photo. They will miscount objects. They will misread text off a whiteboard. They confuse left with right. Because the models are still, at heart, language models, trained to produce plausible text. And plausible text about a picture is not the same as accurate description of a picture. V5 covers hallucination properly. 3 takeaways before the quiz. 1. Image captioning in 2015 was CNN plus RNN. VQA came the same year and forced the field to fuse image and text encoders. Slow, steady climb for 6 years. 2. Clip in 2021 changed everything. Contrastive pretraining on 400 million image-text pairs, 1 shared embedding space, 0 shot classification, and the backbone of every image generator that shipped after. 3. Multimodal LLMs. Staple a vision encoder onto a chat model with a projection layer. GPT-4V, Gemini, Claude 3. Powerful, but they still hallucinate about what they see. Quiz 1. What was the core training idea of CLIP? A fine-tune a CNN on ImageNet labels only. B. Train image and text encoders contrastively, so matched image caption pairs land close in a shared embedding space. On 400 million pairs from the web. C. Use RLHF on a captioning dataset, or D. Train again to hallucinate captions. B. Contrastive learning on scraped web image text pairs. 2 towers, 1 shared space, everything downstream falls out for free. 0 shot classification, retrieval, and the text encoder for every diffusion image generator you have used. Quiz 2. What did the Antol 2015 VQA benchmark ask models to do? A. Generate a caption for an image. B. Answer natural language questions about an image by fusing an image encoder and a text encoder. C. Detect all objects in an image with bounding boxes. Or D. Translate captions between languages. B. Visual question answering. How many people wearing hats? Is the umbrella upside down? The task forced multimodal fusion. Captioning was 3-1. VQA was the harder sibling, reasoning about a picture, not just describing it. Quiz 3. How do modern multimodal LLMs, like GPT-4V, typically connect vision and language? A. Retrain the LLM from scratch on image tokens only. B. A pre-trained vision encoder, often clip-descended, plus a projection layer that maps image features into the LLM's token space. C. Feed the raw pixels straight into the transformer as is. Or D. Use a rule-based bridge from bounding boxes to text. B. Encoder plus projector plus LLM. The encoder handles the seeing. The projector translates vision features into something the LLM can consume. The LLM handles the reasoning and the reply. Standard recipe across GPT-4V, Gemini, and Claude 3. Back to the puzzle. Grounding words in pixels does something you cannot fake with more text data. It gives the model something to point at. The chat box we saw in Vone now consumes pictures as easily as it consumes questions. Next video, what your writing style secretly reveals about you. Next time, what your writing reveals about you, author profiling, stylometry, and the ethics of forensic linguistics. The uncomfortable truth about what a paragraph of text can tell a model. Hit subscribe.